Welcome to the Modus booth here at SMT Hybrid Packaging. Delighted to be joined by Gerald Landt, who's the Geschäftsführer.
Yes.
Yes, or co-partner, I guess.
Yeah, I'm a co-partner from Klaus Frank. I'm still 9 years in the company and promoting conformal coating AOI systems or CCI systems.
Right, okay. Yeah, well, when I first met you, it was AOI systems, but you've recently brought out this really interesting coding measurement system, which we're going to talk about now. Does it have a name, first of all? Do you have a name for the system?
We have two names. One is the standard name is the Modus AOI and MLD1200, or the S3 systems, which is describing the size of the scanner unit. So the MLD1200 is 300 by 400 millimeters, and the S3 is 420 by 540 millimeters field of view.
Okay, so that relates to the size of the sample it can take.
Right.
Yeah. So let's start to talk about the system itself. The boards are mounted in a rack system that goes through the machine, and the first thing we look at is coverage. Is that correct?
Right. First is if you have a coating machine, to check if everything is working well and the material is on the right place on the board. So we check coverage, and even we check bubbles, delaminations or scavening effects, foaming and splashes, and even on areas which is not allowed to have coating. So we mask or demask it on that. But we can check as well areas which is normally not used for coating, and especially when the drops is falling off or in a process. Could happen that something works wrong in that.
I mean, that's typically the case when people are coating. They might mask some of the key components or connectors, but they use a deposition system that gives a tight line definition to try and apply the conformal coating.
Right.
So your system checks for coverage, but the unique thing is that it also checks for thickness.
Correct. Yeah, we have established last year a method which is since 40 years very well known in the medical industry. We take the fluorescence out of the material and we check the thickness according to the brightness of the fluorescence.
Right, yeah. And that's critical for applications like LEDs and this type of thing.
Yeah, it could happen. That is quite critical. So you have an even power management of your LEDs. You need UV LEDs with a special frequency. So we use normally 365 nanometer LEDs usually, but we can use other LEDs what is available on the market.
The coating thickness, what I'm saying, has a direct relation to the luminance that comes off the lamp.
Correct. This is a direct correlation, but it's a non-linear function. It's like a curve where we have to take it on it. We use German university to establish this equation, and we put this in our software that we can find depend on the fluorescence. We have a direct indication for the thickness.
Right. Okay. So for the benefit of our viewers, Gerald, can you give us a demonstration on how you can look at the coverage here and then translate direct to the thickness testing?
All right. So I would start. So when you see over here, we have just the UV fluorescence, and we start with a direct indication. When we slide over, that we have a color indication. So this color indication starts from a darker area to a light green and to a dark blue, where we see some indications in the thickness, especially when we see the curve over here. We have the measurement curves, and even what is interesting, you can just move the mouse area and you see the thickness in micrometer over here. Even when you see the scaling effects over here, or when you move to components, which is usually coated, but you see it's only 4 or 2 microns over here, but you see this area is coated, so there was a coating, but due to the scaling effect, it falls off, or as it was, and you see this very good indication that is very, very low. So that you see directly, this is affects your coating machine. That okay, I have something to do to reprogram my coating program, and even you see it very well that the coating all over the areas looks very nice, and even the coverage of the termination is good or it's not good, and gives you a good indication on that. So all the data will be traced, and you will be as well give a feedback. We have a software to we can feed the coding machines with the X and Y data where failures are occur, and they can get as well this information in their machines.
So, I mean, what would an operator do with this? Could they bring it out and do a manual touch-up, or would you reprogram the coating?
So the future will be reprogramming. So there's an Industry 4.0 or the smart factory application, so that you have a real close loop, that you get all the indication into the coding machines, that okay, you have to do something, reprogram.
That small area.
Yes, even in that small area.
You don't want it to recoat the whole thing again.
No,
you just want to do just that area.
Right. Even some coding is not repairable, so I don't know what should be done after that. Even you have to throw away or to make a new board with a new coating.
Depends on the value of the board.
Exactly, right, exactly, right.
Right. So one of the things with conformal coating as well is if it doesn't bleed over the edge, you can get ingress coming in from the edge of the board. You've got a version that has got a side camera that can help you to inspect that as well.
Yes, especially if it's on the side or on high components. We have a system which moves the mirror, that we have a side view, that we can go for high components or on areas which normally cannot use from a 90 degree from the top side. So some information are missing. So therefore we have a side view as well. It's possible to have a machine with that, yes.
Good. Okay, well, Gerald, lovely product, interesting ideas that you're always coming out with. Thank you for showing it to us today.
Thank you very much, Trevor.